Hey guys, so in the previous video we were talking about the isomers. We saw that isomers could be made by either making a branch from the main carbon chain, from the center obviously, or you can have an isomer by having a changed position of the carbon-carbon double bond. So if the carbon-carbon double bond is in the center, you can push it on the corners, and if it's on the corners, you can push it in the center. Now we're gonna try some past paper MCQs to have a practice, and then we'll obviously jump onto paper 2 as well, so that we know what we are learning and how we can apply that. So I have my past paper booklet here. We're gonna try some questions related to isomers and perhaps main structures of alkanes and alkenes. So just to revise stuff, So butane and methyl propane are isomers. I know one thing, that they're isomers, so I'm gonna underline this part. What formula is different for these two? So I know they have same empirical formula, they have same molecular formula. Since they are part of alkanes, since they are both alkanes, they are alkanes. Both are kind of alkanes, so they have same general formula. They should be having different structural formula because they have different structures. Let's try this question. Methane, the first member of the alkane homologous series, has a boiling point of minus 161. So methane has a boiling point of minus 161. Okay. Which molecular formula and boiling point could be the correct for another alkane? So another alkane की बात हो रही है यहाँ पे. Another does not mean necessarily ethane. It could be any other alkane as well. But let's see. They're giving you molecular formula. So C2H4 is not even alkane. Not alkane. Not alkane. C2H6 is ethane. C3H6 is not alkane. So again, not alkane. It can be either B or D. B is ethane, and ethane is given the boiling point of minus 185, but you should know that longer chains have higher boiling point. We did talk about this. So if methane is minus 161, ethane should be higher, and apparently minus 185 is not higher. So minus 185 is lower. That is why B is incorrect. Minus 185 is not actually higher than minus 161. It's lower. In negative, the values run oppositely. So it should be D for doctor. Propane has a higher boiling point than methane. So obviously minus 42 is very much higher than minus 161. So D is correct. Let's try any structure. Let's try this one. The diagrams show 4 hydrocarbons P, Q, R, S. Which 2 hydrocarbons are isomers of each other? So they're looking for isomers over here. Let's try to find out that there's a structure which is a 3-carbon alkane. It's 4-carbon alkane, 4-carbon alkene because R has a double bond, and then S is a branched structure. So let's see. It is a propane. This one is a butane because it has 4 carbons and no carbon-carbon double bond. This one is a butene, and this one has a branch, so it's a branched butane. So let's call it isobutane. It has 4 carbons, but 3 are in a chain, and 4th one is a branch actually. So Q and S have to be the isomers. So D for doctor is the right answer. That butane and isobutane, because this one is unbranched and this one is branched. Let's try this one. In which of the following are all the compounds member of the same homologous series? So they should follow the same general formula, because same homologous series means by definition same general formula. So CH4, C2H6, they're both alkanes. C3H6 follows the general formula of alkene. So C3H6 cannot be alkane, and that is why it's incorrect. B is CH4, C2H6, so both are technically alkanes, methane and ethane. Then C3H8, C3H8 is actually propane. So B seems fine. Let's confirm with C and D. C is C2H4, which is ethene, because hydrogens are double the number of carbon, and this happens in alkenes. So C is ethene. Then C3H6 is propene, but then it's C4H10. and 10 is not the double of 4, so it's not alkene. That is why it's incorrect. Let's confirm with D. C3H4. Sorry, it's not even a general formula. Hydrogen should be double the number of carbon, or it could be more, but it's very less. 4 is not the double of 3. So D is already incorrect. So B is the right answer. Yeah, let's try this one. The disparate formula of two compounds are shown. What are the similarities and differences between the two compounds? We haven't tried oxygen at any point in the structure, but let's see that what is similarities and differences. Okay, this one seems to have an oxygen carbon double bond. This one also has it. This has OH over here, but this doesn't have OH, so it's just O. I think that's different. What is different is different structures. So they have different structures, but apparently their formula seems to be same. See, 1, 2, 3 carbons, so it has 3 carbons over here. Hydrogens are 1, 2, 3, 4, 5, 6. So there are 6 hydrogens over here, and oxygen are 2. This one also seems to have 3 carbons, 6 hydrogens, and 2 oxygens. So they have same molecular formula, but their chemical and physical properties will be different because they are isomers. Their structures are different. So they have same molecular formula, but they have different reaction, which means chemical properties. Their chemical properties would be different. They don't have same structure. They don't have same structure. They have same formula, but their masses cannot be different. So A is the right answer, where they have same molecular formula, but apparently their reactions would be different. Which property of the alkanes do not increase as the relative molecular mass increase? We know this property. We already know. Okay, their boiling point increases, their melting point increases, their viscosity increases, but their flammability decreases. So if a longer alkane is there, its flammability would be less, and for shorter ones it would be higher. So flammability doesn't increase, it decreases. This question seems good. A compound known in industry as MTBE is known as an additive in the lead-free petrol. The structural formula of MTBE is shown. Okay, which compound is an isomer? So I'm gonna zoom out a little because we want to see all the structures. Yeah, which compound is an isomer of MTBE? So this one is MTBE over here, but let's find out the isomer over here. So I can see the formula is 5 carbons. Hydrogens are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it has 12 hydrogens, and it has 1 oxygen over here. So 1 oxygen over here. Let's see which one has 5 carbons. This one has 5 carbons and 1 oxygen, but hydrogen can be counted in option A. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, sorry, it has not the same number of hydrogens, so the formula cannot be same. It is something C5H10O. So A is not the answer. Option B has 4 carbons, so C4, already not the answer. Option C is gonna be 5 carbons. Yeah, it is 5 carbons, I can see that. Hydrogens are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 1 oxygen. So yeah, that seems fine. It has the same formula, which is C5H12 and O. Okay, that's great. So C is already the answer, just confirming with D. 5 carbons are here. Hydrogens are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, again, not the same number of hydrogens. So that is again not the answer, because isomers have the same formula but different structures. So C was the answer. Okay, I'll remove this one over here. I don't know why I had it, but let's try this one, and this would be our last MCQ for this video, where we are saying over here that the diagram shows 4 structures. Which structures are isomeric butenes? So they want isomeric butenes. Let's find out. The first one is not even a butene, It has no carbon-carbon double bond. It is not a butene, it's a butane. It's a 4 carbon butane alkane, because it doesn't have a carbon-carbon double bond. So I'm going to move it a little over here. Let's talk about this one. Yeah, it is 4 carbon compound with a double bond in the center on the corner. So yeah, that's a butene. You can see double bond is in the carbon, on the carbon which are on the corner. ठीक है जी. Let's for option, this is third compound. It is a 4 carbon compound. I can see that, yes, but it has 2 double bonds, and that is why it has a different molecular formula. So it's a butene, but it has 2 carbon-carbon double bonds. So I'm a little skeptical about this one. For option 4, I can see it's also a 4 carbon compound, and it has a double bond in the center. So directly this is the answer. It's an isobutene, because this one has a double bond in the center, and this one has a double bond in the corner. So yeah, option 2 and 4 is the right answer, because 1 is not even a butene, 3 has 2 double bonds, and you know the formula is different over here. So we know the answer, and that is why 2 and 4 are the butenes. So let's keep it till here. In the next video we'll be solving some P2 questions as well, guys, so just stay tuned. I'm really hoping that these videos are helpful for you. Take care, guys.